Hello, my name is Ardi and we are going to solve practice problem 10.1 from Sadiku book, and we are given this circuit here, and the question is using nodal analysis find V1 and V2 in the circuit. So the circuit is in with an AC current circuits, and we have here the current is 10 cosine 2t. Okay, let's write that. So we'll have 10 cosine 2t, but 2t we can write it with plus 0 degrees, right? Okay, so now we have this current source, this one. Now let's break this down. So this is the omega here. So we will have omega here, and this is the phase, and this is the amplitude. Or we can write it in phasor, which is a representation of complex number in a polar coordinate. So we take this amplitude, which is 10, and only the phase, which is 0 degrees. Okay, so now we save this omega value here because this value is very important in solving this problem. So our omega is 2, the unit is radian over second. Okay, now we want to transform this circuit into frequency domain, and we need to take care of the capacitor and the inductor. Now for the capacitor, so our capacitor is 0.2 farad, and this is in the time domain. So to change it into frequency domain, we just plug in into the formula, which is 1 over j. J is the complex number, omega c, and our omega is 2. So let's just plug it. So we'll have 1 over j, our omega is 2, and then c, the value of c is 0.2, so we'll have 0.2, and that will make this 2.5 over j farad. But we don't want j to be in the denominator, so I can multiply this by j over j. So j multiplied by j is minus 1, so I will have minus 2.5 j here. Okay, and now for the inductor, so we'll have the inductor, I will have 2 Henry, and we are transforming it into frequency domain, and the formula is j omega L. Let's plug that in. We have j, omega is 2, and the inductance is 2 Henry. So we will have 4j. Okay, now let's replace all the values in time domain into frequency domain. Let's do that. Okay, now we have our new circuit here, but with the values of current source, capacitor, and inductor replaced in the frequency domain. So this one will be 10 angle of 0 degrees. This is minus 2.5j, and this is 4j. The reason we change into this is because we can treat this capacitor and inductor just as resistor, but that involves complex number, so I recommend you to use calculator that able to calculate any operation of complex number, addition, multiplication, division, and converting from polar coordinate into Cartesian coordinate. So yeah, this is my calculator and it works very well with it. Okay, now let's jump into the problem. Now we need to find V1 and V2 using nodal analysis. So nodal analysis, we need to assume all the direction of the current. So let's assume this current is going there, this is going there, this is there, and this is there, and that is there. Okay, so now let's do KVL at V1. So we need to do KCL, not KVL, KCL at V1. And KCL said that the sum of the current that goes in is equal to the sum of the current that goes out. Okay, this is our first step. And the only current that goes in is this current here, which is 10 angle of 0 degrees. Okay, now we need to calculate the current that goes out. The first one is this one, V1 divided by 2. So I will use different color for our variables, which is V1 and V2, because we need to differentiate numbers and variables easily because we have J and stuff. So I'll have V1 divided by 2 here. And then this current that goes out, so plus, we will need to get this V1 over V2. V1 minus V2, V1 minus V2, V1 minus V2 divided by this one. We can treat capacitor here as a resistor, just like a resistor. So I will have minus 2.5 J. So that's all the current that goes out. So only two currents that goes out. Okay, now 10 angle of 0 degrees. This is in polar coordinate. We can change it into Cartesian coordinate, which is just 10, right? I want to work in Cartesian coordinates. Okay, now we have this equation here, and I want to multiply both sides by 10J, right? Because I want to get rid of all this denominator here, and I want to work without denominator. That's important. So we will get 100J. 10 multiplied by 10J is 100J, and that will equal to 2 multiplied by 10J is 5J. So I will have 5J and V1 right here. And now we will get this one, minus 2.5J multiplied by 10J is just minus 4, right? Minus 4, so I will have this one, minus 4 V1, and then no, this is J times J is minus 1, so 10 divided by 2.5 is 4, right? 4, so I will have plus V1 and then minus 4 V2. Okay, I think I made a mistake, so this J will cancel each other, so this is minus 4, so our sign here should be this one. This will be minus, this one will be minus, and this one will be plus. Okay, so now we'll have 100J, and then we group this together, V1 and V1, so I will have 5J minus 4 V1, and then plus 4 V2. Okay, now this is the best way that we can do for now, so let's save this as equation number 1. Okay, now let's move on to another nodes. So let's do KCL at V2. I have KCL at V2. Remember that KCL is the sum of the current that goes in is equal to the current that goes out. Okay, now the current that goes in is only this one, so I will have V1 minus V2 divided by minus 2.5J minus 2.5J, and then that will equal to the current that goes out here. We will have V2 divided by 4J, V2 divided by 4J. Oh, what's that? And then we will have this one, V2 minus this node, and this node is 3Vx. Remember that this is 3Vx because our bottommost node is our ground, and 3Vx, because Vx is here, it is the same as V1, so 3Vx is equal to 3V1. Okay, now this one should be V2 minus 3V1, so I will have V2 minus 3V1 divided by the value of that resistor. Okay, and now I want to multiply both sides by 20J. So I will want to get rid of all the denominator, so I multiply all of this by 20J. And that will give us minus 8 here, minus 8 of V1, and then plus 8 of V2, 8 of V2, and that will equal to 5V2, right? This will get to 5, right? 5V2, and then plus 4 with 20J will cancel out into 5J, so I will have 5J of V2, and then we will have this one should be minus 15J V1. Okay, now let's group them all together. So we will have this one, V1 and V1, so I will have 15J minus 8 of V1, and then for all the V2 we'll have 5J plus 5 minus 8 is minus 3, so I will have that equal to 5J minus 3 of V2. And then we can move this one to the right hand side, so I will have V1. Okay, I run out of space, so let's do it here. Let's do it here. V1 is equal to 5J minus 3 divided by 15J minus 8 of V2. Okay, let's save this as equation number 2. And now we have two equations with two variables. We should be able to solve this. Okay, so far we got these two equations here. This is from node 1 and this is from node 2. So we have two variables with two equations. We should be able to solve this. And now how to do that? We need to substitute 2 into 1. Okay, let's write that. Substitute 2 into 1. Okay, now let's write 1 first. So we'll have 5J minus 4 and then V1, and V1 is this value, right? Let's plug that in. So I will have this multiplied by 5j minus 3, and then we'll have 15j minus 8 of V2, right? And then this one plus 4 V2, and we will have 100 joule. Okay, for this one I just group them together. 5j minus 4, 5j minus 3 divided by 15j minus 8 of V2. And now because this is 4, only 4, we need to make the denominator is like this one, so we can add them together. So I'll have 4. I multiply this one with 15j minus 8 divided by 15j minus 8 of V2, and that will equal to 100 joule. This works because this is 1, right? We can cancel this and this. Okay, now because the denominator is the same, we can just combine them. So I will have this, all of this in the left hand side. So I'll have 5j minus 4, and then 5j minus 3 plus 4 15j minus 8 divided by 15j minus 8, and that all multiplied by V2, that will get you to 100 joule. So we can cross multiply both sides. So I'll have V2 is equal to 100j multiplied by this one. So I'll have 15j minus 8 divided by all the numerator value here, 5j minus 4, 5j minus 3 plus 4 15j minus 8. Okay, now times to grab our mighty calculator here and calculate this into simple form. So from my calculator, I will get the result is 17.9245 plus J 27.7358. This is in Cartesian coordinate, or in the phasor or polar coordinate, this will be 33.0237, and the angle is 57.1271 degrees, and the unit is volt. Now because this is in frequency domain, we need to take it back into time domain. So V2 in time domain. Okay, now to get it back to the time domain, this is the amplitude. So we'll have 33.0237, and then our initial function is cosine, right? So we'll have cosine here. So we get it back into cosine, and cosine, remember that we have omega here, omega. Our omega is 2 radian over second. So our omega is 2. This is from here. And then that is cos 2t, and plus our angle here. So we'll have 57.1271 degrees. This is for V2. Okay, this is for V2. And now how to find V1? We can simply substitute V2 into equation 2. Okay, now let's do that. Let's make some line here. Okay, we will have V1 is equal to 5j minus 3 divided by 15j minus 8 of V2. So I will have V2 here, so we can just plug this Cartesian or polar coordinate into calculator. That is no problem. So I will have 5g minus 3 and then 15j minus 8, and we multiply this by this one here, 17.9245 plus j 27.7358. Okay, now we get the result from here. I will have V1 is equal to, okay, let's get it, 5.6604 plus j 9.5113. This is in Cartesian coordinate. So in polar coordinate, you will have V1 is 11.3270 and the angle is 60.0184 degrees. Okay, this is in frequency domain, so let's convert it into time domain. So V1t will equal to, this is the amplitude, 11.3270, and then cosine like before, and then 2t because the omega is 2, and then plus the angle, which is 60.0184 degrees, and the unit is volt. So we get V1 and V2 for the problem 10.1. I think that's all for problem 10.1. Hopefully I did not make any mistakes in the calculation. Let me know if I did, and thank you for watching. Bye bye.